In this video, we will learn about binary search tree. Binary search tree is a special type of binary tree where the left child of a particular node value will be less than the root or the parent, and right child value will be greater than the value of the root or the parent. So suppose if you have duplicate values in the construction of the binary search tree, how it will be handled? There are three possible cases. The first one is, first of all, we have to see to that there should be like no duplicate values. If at all, if it is there, we have to ignore them. Like that we can consider in the first case. The second case is like if we have duplicate values, we should follow a consistent process, that is, equivalent value should be given as a left value all the time, or it should be given right value all the time. It is not like one time we will create as a left child and sometimes we create as a right child. Like this, randomly we are not supposed to do. We have to follow a particular consistent process, that is, always we have to enter the equivalent value or duplicate value as a left child or either right child, like that. And the other one, that is the third case, is for every node we'll keep a counter. So whenever a particular node value is repeated, that is duplicate value is coming, then we will increment that counter value. So it indicates like how many times the particular count value is occurring. Let us see how we can create and insert a values in the binary search tree. So this is a sequence given to you. So obviously the first value will be the root node and 35. Now 35 will be compared with 50. Because 35 is less than 50, it will become as left child of 50, like this. And the next value is 28. Now again it start with 50. 28 is less than 50. So come to left of 50. Now again 28 will be compared with 35. Because 28 is less than 35, we have to insert as left of 35. Like this. Then 73. 73 is greater than 50. Insert as a right child of 50. So 73 will be the right child of 50. The next one is 85. 85 is greater than 50. So move towards right of 50. 85 will be compared with 73. Now because 85 is greater than 73, 85 becomes the right child of 73. Next one is 20. 20 is less than 50. Compare with 35. 20 is less than 35 and then 20 is less than 28. So 20 will become left of 28. Then 40. 40 is less than 50. So it will be compared with 35 and then because 40 is greater than 35, it will be inserted as right child of 35, like this. Okay. So this is how we will create and insert values into the binary search tree. Now let us consider deletion operation in the case of binary search tree. This is the given tree structure. We want to delete 28. 28 is the internal node. And now we can observe that 28 is having only a single child, that is 20 as a left child. So when we are deleting a node with a single child, what we'll do is we'll replace the node with it simply. That because 28 is having 20 as a left child, 20 will be replacing 28. So here if you observe 28 is replaced with 20 and 25, because it is right of 20, it will be same as it is right of 20 here. Okay. Then next one, deleting 35. Now here if you see where is 35, here. Deleting 35, you are having two child nodes, that is left and right, both are there. Now here one point is either we can replace the node from the left subtree or right subtree. So if you are replacing from the left subtree, it should be the maximum value. If you are replacing from the right subtree, it should be the minimum value. In this particular example, we are replacing with the right subtree, but because we are having only single value in the right subtree, we are replacing that with the node what we are deleting. So 35 we are replacing with 40. Here like this we will be getting it. Now the same 35, same tree structure I have considered. I am showing you how we can delete the value by replacing it from the left subtree. As I told you, the maximum value we are supposed to take from the left subtree, because the maximum value out of left subtree, that is 28, 20 and 25. 28 is the maximum. So we will use 28 to replace 35. So 28 will go to the place of 35 and the rest of the tree structure will be remaining as it is. So when we delete 35 and replace the node with maximum value from the left subtree, we will get the tree structure like this. The next example is deleting 50. That is root node we want to delete. The same procedure we will follow as in the case of internal node with the two child nodes. So because we are having both the child nodes, that is left child and right child, so in the case of root, left subtree we can use or right subtree we can use to replace it. So now if you observe here, if you are considering left subtree, the maximum value is 40. 40, 35, 28, 20, 25. 40 is the maximum value. So we will use 40 to replace 50. Like this we can get the tree structure after replacing 50 with 40. Then let us consider what will happen if you are replacing with the node of the right subtree. So right subtree minimum value is 65. So we can also replace 50 with 65. This is another possibility. Either way we can do. But throughout the process, we have to follow only one procedure. Either you follow by taking the maximum value from the left subtree or minimum value from the right subtree. Here we are showing like for both the cases. Thank you.